to Sunil's tutorial. I'm Sunil Mirwani and today we will be doing the numericals of measurements. Take on please. Find the dimensions of power. Find the dimensions of power. Find the dimensions of power. Now whenever I ask you to find the dimensions, the first thing that you have to do is you have to write the formula for that particular unit. Now power is defined as work upon time. Work is defined as force into displacement upon time. Force is defined as mass into acceleration into displacement upon time. Acceleration is defined as displacement upon time square. Mass into displacement upon time square into time. So you have to first thing write the formula and convert it into fundamental units. Once you have converted it into fundamental units, then you can find out the dimensions. So dimensions will be mass. There is only one mass in it. Length 2. Time is in the denominator 3, so minus 3. When I bring it in the numerator, it becomes negative. Next, find the dimensions of force. Find the dimensions of force. Find the dimensions of force. Force is given as mass into acceleration. Right? Force is given as mass into acceleration. Right? Mass into acceleration. Displacement upon time square. Right? So in that case, dimensions of force is m1, l1, t minus 2. Right? Next, take on next one. Find the dimensions of permittivity of vacuum. 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 Now, permittivity of vacuum, epsilon 0, is given to you as Q1, Q2 upon 4 pi r square F. That is what is your formula for epsilon. Now, charge is nothing but current into time. Charge is nothing but current into time. 4 pi. Radius is nothing but length square. Force is nothing but mass into acceleration. This is current into time. Current into time. 4 pi L square. Mass is m1. Acceleration, or let's leave that mass as it is. Acceleration is displacement upon time square. Right? So in that case, denominator of denominator becomes numerator. Denominator of denominator becomes numerator. So this is IT, current into time into time square upon 4 pi L square m into S. Now in that case, my dimensions of epsilon 0. Now mass is in the denominator, so m minus 1. Length and displacement both in the denominator, right? And displacement is also length, so L minus 3. Current time 2, 3, 4. Besides that, you have current. Current is a fundamental quantity, so current square. So dimensions of epsilon 0 is m minus 1, L minus 3, T4, current square. Right? Next. Take on next one, please. Derive an expression. for kinetic energy. Derive an expression for kinetic energy using dimension analysis. Derive an expression for kinetic energy using dimensional analysis. Derive an expression for kinetic energy using dimensional analysis. Now, from experiment, we know that kinetic energy is directly proportional to mass. Kinetic energy is directly proportional to velocity. Therefore, I can say that kinetic energy is directly proportional mass raised to x, velocity raised to y. We don't know what power it is. Velocity raised to y. Therefore, I can say that kinetic energy is equal to k times mass raised to x and velocity raised to y. From experiment, we know that kinetic energy is directly proportional to mass, some form of mass, so mass raised to x. Kinetic energy is directly proportional to velocity, some power of velocity, so velocity raised to y. Therefore, I can say kinetic energy is directly proportional to mass raised to x and velocity raised to y. So kinetic energy is mass raised to x, k times mass raised to x and velocity raised to y. Now let's find out the dimensions. Dimensions of kinetic energy. Energy is the capacity to do work. Work is defined as force into displacement. Force is defined as mass into acceleration. Acceleration is defined as displacement upon time square into displacement. Therefore, I can say that dimensions of kinetic energy is going to be equal to m1 L2 T minus 2. Right? Then, I can also say that dimensions of mass will be m1 L0 T0 and dimensions of velocity. Dimension of velocity. Velocity is nothing but displacement upon time. So it will be m0 L1 T minus 1. Right? Now, if the equation is correct, then dimensionally it should be equal. I can say from equation 1, guys, can you please see equation 1? This is your equation 1. Ke is equal to k times m raised to x, velocity raised to y. So, dimensions of Ke, kinetic energy, are m1 L2 T minus 2 is equal to k times m1 L0 T0 raised to x and m0 L1 T minus 1 raised to y. Right? In this case, I can say that m1 L2 T minus 2 is equal to k times m raised to x, right, L raised to y and t raised to minus y, right? So in this case, I can say equating similar terms, if I equate similar terms, then m raised to 1 should be equal to m raised to x, therefore x should be equal to 1. L raised to 2 should be L raised to y, so y should be equal to 2. Thus, I can say that kinetic energy is equal to k times mv square. Right? Once I have this, then by experiment, you can find out the value of k to be 1 by 2, and therefore the expression kinetic energy is equal to half mv square. Right? Do we understand how we derive that expression? Next, take on next one, please. State the order of magnitude state the order of magnitude of G, which is 9.81 meters per second square. State the order of magnitude of G, which is 9.81 meters per second square. Now, 9.81 is approximately equal to 10, right? So in that case, I can say that order of magnitude. What is order of magnitude? When you represent a number in terms of 10 raised to anything, that is order of magnitude. So here, order of magnitude will be 10 raised to 1 meters per second square. That will be my order of magnitude of G. Right? Let's see another term. Say if they give you capital G, 6.67 into 10 raised to minus 11 Newton meter square per kg square. Now 6.67, if I round that up, then that will be nothing but, since the number is greater than 5, then its order will be 10. So I can say G is 10 into 10 raised to minus 11. Therefore G is equal to 10 raised to minus 10. So therefore I can say that the order of magnitude is 10 raised to minus 10 Newton meter square per kg square. Right? So when you are doing order of magnitude, you have to represent it in some power of 10. Suppose if I give you another sum, period of rotation of Earth. Period of rotation of Earth. Right? Period of rotation of Earth we know is 24 hours. Right? 24 hours is nothing but 24 into 3600 seconds. I am converting from hours to second. When you multiply this, this will be nothing but 86,400 seconds. Now, when you have to write a number in scientific form, you have to write it with one significant digit. That means your decimal should come after one significant digit. So if I have to write the decimal here, the decimal is actually here. If I shift it 1, 2, 3, 4, I would have to shift it 4 places. So this is nothing but 8.64 into 10 raised to 4 seconds. 86,400 can be written as 8.64 into 10 raised to 4 seconds. Right? I'm shifting the decimal, guys. Since I'm shifting it to the left, it will be positive indices. Now 8.64, 8 is greater than 5. Therefore, it can be represented as 10 into 10 raised to 4 seconds. So this is 10 raised to 5 seconds. Therefore, I can say that the order of magnitude is 10 to the power of 5 seconds. That's the order of magnitude of rotation of Earth. Fine. Next type of sum. Determine significant digit for the following. Determine significant digit. Right? You have to determine significant digit for the following. Now, first, let's see this. Suppose if I give you 0.05718. Right? Now I told you when you have to write in terms of, this is called as scientific notation. What does scientific notation state? Scientific notation states that your answer should be in form of decimal, and the decimal should be after the first place, first number. That means if I want this decimal after the first number, I have to shift the decimal 2 to the right. So this can be written as 5.718 into 10 raised to minus 2. 0.05718 can be written as 5.718 into 10 raised to minus 2. So how many digits are there here? 1, 2, 3, 4. So number of significant digits are 4. Number of significant digits is equal to 4. Right? Do we get this thing here? So when you want the answer in terms of significant digits, you have to make sure that you are out of all the zeros. You shouldn't have any zeros. Right? Let's see another sum, guys. Let's see, suppose if they give you 2.35 into 10 raised to minus 19. Can you tell me can someone please tell me how many significant digits are there? 3. So number of significant digits. Significant digits is equal to 3. Suppose if you have 1.3725 into 10 raised to 9. Can someone please tell me the number of significant digits? 5. Number of significant digits are 5. All this comes in your MCQs. The numericals I am doing today, most of them will be asked to you in your MCQs. These are not your 2 and 3 marks numericals, these are your MCQ numericals. Let's do now a couple of 2 or 3 marks numericals. I think I've already done similar kind of sums. Let's practice that a little more. Right, take down some of these. An object was weighed by a physical balance. An object was weighed by a physical balance. An object was weighed by a physical balance. And the following readings were obtained. The following readings were obtained: 5.04 grams, 5.06 grams, 4.97 grams, 5 grams, and 4.93 grams. Find the absolute error and percentage error. Right, first let's find out question. So why did you use y? You could have used anything else. You can use anything you want. I felt like using y, that's why I used y. No specific reason why I used y. Right? Now, let's see this. First let's find out the mean value. How do you find out mean value? I'll represent that as ym. Mean is the addition of all the numbers divided by numbers. y1 plus y2 plus y3 plus y4 plus y5 upon 5. Guys, I won't solve the sum, I'll just show you how to get the sum, and then I want you all to solve this right now in the class. Right? Once I finish this.
So mean value and average value is the same?
Same thing, yes. Mean value and average value is the same thing. Right? These are different terminology for the same thing. Then you find out absolute error. How do you find out absolute error? Absolute error, that's delta y, is nothing but mean value minus the given value. So absolute error will be mean value minus the given value. Absolute error 2, mean value minus the given value 2. Mean value minus the given value 3. Mean value minus the given value 4. And mean value minus the given value 5. Those are going to be your absolute errors. I am not showing you the calculations, you all will do that on your own. Then, relative error. Relative error is nothing but the mean of absolute error. Right? So, mean of absolute error, how do I write this? Relative error is modulus of delta y1. That means if I've got the value of delta y1 positive or negative, I will take positive value plus modulus of delta y2 plus modulus of delta y3 plus modulus of delta y4 plus modulus of delta y5 divided by 5. Right? Once you have this, then you can find out percentage error. Percentage error is nothing but relative error divided by mean value into 100. Solve the sum, you should get your final answer percentage error as 0.836%. I want the sum solved in the class right now, okay? Next, take on next sum please. A diameter of a wire is measured using micrometer screw gauge and was found to be 0.74 millimeter. If the least count of the screw gauge is 0.001 centimeters, find the percentage error in its measurement. Find the percentage error in its measurement. Now guys, let us assume that I represent the diameter as y, 0.74 millimeters. Now since the least count is given to you in terms of centimeters, I should represent my reading also in terms of centimeter. How do I do that? This can be written as 0.74 into 10 raised to minus 1 centimeters, right? Least count is the error in y, 0.001 centimeters, right? They have asked you to find out percentage error. Percentage error is least count divided by reading into 100. You can do your calculation and get the answer. The answer for this should be 1.35%. Take down next sum please. The radius of a spherical ball is 4.32 plus minus 0.01 centimeters. Calculate the percentage error. In the measurement of volume. Calculate the percentage error in the measurement of volume. Now, they have given you that the reading is 4.32 centimeter and the error in reading can be 0.01 centimeters. Question, sir, why using R? Why not Y? Use Y. So please don't get confused here, right? Now they have asked you volume. Volume of a sphere is 4 by 3 pi r cube, right? Volume of the sphere is 4 by 3 pi r cube. That means when you are measuring this, you will be measuring radius 3 times. And if you are making this error once, you will be making this error every time you measure the radius. That means the error is going to be committed 3 times. So the error in volume, relative error in volume, that is delta V upon V, is going to be, I am making an error of delta R upon R 3 times. Why 3 times? Because this is R cube. So once I have this, you know what is delta R, you know R, you can substitute and get the value of relative error. Once you have relative error, then you can find out percentage error. Percentage error is nothing but relative error multiplied by 100. Percentage error is nothing but relative error into 100. Right? Take on the next sum. The answer for this sum should come to, answer is 0.64%. Next, using dimensional analysis, show that 1 joule is 10 to the power of 7 ergs. Using dimensional analysis, show that 1 joule is 10 to the power of 7 ergs. First of all, joule and ergs are the SI unit of work. Joule and ergs are SI unit of work. Right? Now, in that case, what is the dimension of work? Dimension of work. Work is nothing but force into displacement. Force is mass into acceleration. Acceleration is nothing but displacement upon time square. Right? So that is for this. And force into displacement. So L2 T minus 2. I've done this already. You could have written the formula and done it. So this is going to be M1 L2 T minus 2. Right? Now, let us assume, let M1 raised to 1, L1 raised to 2 and T1 raised to minus 2 be the dimensions, and you write both together, and M2 raised to 1, L2 raised to 2 and T2 raised to minus 2 be the dimensions, of work in SI and CGS units. Now, since both are dimensions of work, dimensionally they should be equal. That means M1 raised to 1, L1 raised to 2, T1 raised to minus 2, that is your SI unit, should be equal to, say, X times the CGS unit, M2 raised to 1, L2 raised to 2 and T2 raised to minus 2, right? In which case I could say that X should be equal to M1 raised to 1, L1 raised to 2, T1 raised to minus 2 upon M2 raised to 1, L2 raised to 2, T2 raised to minus 2, right? Now, this can be written as X is equal to, therefore, M1 upon M2 raised to 1, L1 upon L2 raised to 2 and T1 upon T2 raised to minus 2. Right? Now M1 is the unit of mass in SI unit. So this is going to be 1 kg upon 1 gram. This is 1 meter upon 1 centimeter. And this is 1 second upon 1 second. This gets cancelled, right? 1 kg can be written as 1000 grams upon 1 gram. 1 meter can be written as 100 centimeter upon 1 centimeter. This is 1 raised to anything is 1. So your gram and gram gets cancelled and centimeter gets cancelled. This is 1000 into 100 square. 100 square is nothing but 10 raised to 4 into 1000 is 10 raised to 7, and that's what we have to prove, that 1 joule is 10 to the power of 7 volts. Right? Take down next sum please. the hydrostatic pressure is given by the formula P is equal to K times H raised to X, D raised to Y and G raised to Z. Find the value of X, Y and Z. Find the value of X, Y and Z. The hydrostatic pressure P is given by this formula. Hydrostatic pressure P is equal to K times H raised to X, D raised to Y and G raised to Z. Right? You have to find the value of X, Y and Z. Now this is similar to that kinetic energy sum. Right? Pressure. Pressure is defined as, guys, pressure is nothing but force upon area. Force is mass into acceleration into length square. Mass, acceleration is displacement upon time square into displacement square. So in that case I can say that dimensions of pressure will be m1 L minus 1 T minus 2. Fine. Next, dimensions of height. Height is going to have only L in it, m0 L1 T0. Then you have density. Density is nothing but mass upon volume. Volume is nothing but length cube. So mass upon length cube 0. And the last is G, gravitational acceleration. Acceleration is nothing but displacement upon time square. Displacement upon time square. So I have written all the dimensions. Now if I substitute these dimensions in the equation, then I can say that therefore m1 L minus 1 T minus 2 should be equal to K times L1 raised to X, m1 L minus 3 raised to Y and L1 T minus 2 raised to Z. I just substituted the dimensions, in which case I can say that m1 L minus 1 T minus 2 is equal to K times, this is going to be m raised to Y, because see this m raised to 1 raised to Y is m raised to Y, L raised to X, and here you have L into L raised to Z. Law of indices, A raised to M into A raised to N is A raised to M plus N. So this can be written as L raised to X plus Z, right? L, you also have Y here. L raised to X minus 3Y plus Z, L raised to X minus 3Y plus Z, and T, there is no T here, T raised to minus 2Z. Then I can say, equating like terms, I can say m raised to 1 is m raised to Y, therefore Y is equal to 1. Then I can say that T raised to minus 2 is T raised to minus 2Z, therefore Z is 1. And finally, you can also say that L raised to minus 1 is L raised to X minus 3Y plus Z. So minus 1 is X minus 3Y plus Z, out of which I know the value of Y and Z as 1. So minus 1 is X minus 3 plus 1. I substituted the value of Y, I substituted the value of Z. Minus 1 is X minus 2. 2 minus 1 is X. X is equal to 1. Thus, you found out all three values, X, Y and Z. Right? Take our next sum, please. E is equal to 2 pi root of L by G. Verify the equation dimensionally. Verify the equation dimensionally. Verify the equation dimensionally. Dimensions of t. T stands for time, right? Dimensions of time is going to be m0, l0, t1. Length is going to be m0, l1, t0. Gravitational acceleration, displacement upon time square. So displacement upon time square, right? Let's find out the dimensions of RHS. Dimensions of RHS, 2 pi root of L by G, right? 2 pi is a constant, it has no dimensions. So this is going to be root of L by G. Now this is nothing but L raised to 1, L raised to 1, T raised to minus 2 under root. I've just written the dimensions of length and gravitational acceleration, what I had already found out. L and L gets cancelled. From denominator to numerator, when I take, the sign of indice will change. So T raised to minus 2 will become T raised to 2 square root. Square root of T raised to 2 is nothing but T raised to 1. And T raised to 1 can be written as M0, L0, T1, which is nothing but the dimensions of time, which is nothing but my LHS. Thus, the equation is proved.
So the 2 pi is constant in my terms.
2 is a number. Number does not have dimensions. Pi is also a number, constant number. It does not have dimensions. It is only fundamental units that have dimensions. Fine. Next. Take on next one, please. The percentage error. The percentage error in volume V of a block of length 10 centimeters, breadth 20 centimeters and height 15 centimeters. Can you repeat the sum, guys? I think I made a mistake in the dictation of the sum.
Percentage error.
The percentage error, no, right? Find the percentage error. Find the percentage error in the volume of a block of length, breadth and height. Okay. Now this is the data given to you. If, continue please, if the measurement is carried out on a meter scale. If the measurement is carried out on a meter scale. Now, since the measurement is done on meter scale, what is the least count of a meter scale, guys? 0.1 centimeters. That is the smallest length. Least count is nothing but 0.1 centimeter. And error is always equal to the least count. That means the error, I am writing error as D. Error in measurement of L is 0.1 centimeter. Error in measurement of B is 0.1 centimeter. And error in measurement of height is also going to be 0.1 centimeter. Now, volume. Volume is nothing but length into breadth into height. Right? I will make an error in the measurement of length plus breadth plus height. When you are doing error, multiplication changes to addition and division changes to subtraction. When you are doing error, multiplication changes to addition and division changes to subtraction. So therefore I can say that relative error dV by V is nothing but dl by L plus dd by B plus dh by H. You have all the values, you can substitute and get your answer. Right? You should get the answer for this as, this is, I didn't multiply this, I have to find out percentage error. I can say percentage error is relative error into 100. Whatever answer that you get, multiply that by 100, you will get your percentage error, and you should get this answer as 2.17%. Right? We'll stop this here for the day. Thank you very much.